Chapter 2, Section 1 is all about functions, equations, and graphs. A relation is a set of pairs of input and output values. So anytime that you have two pieces of information, one of them relates to the other, you call that a relation. There are 4 ways to represent relations. The first is through ordered pairs, where you list the input first, the output second. So make sure you put parentheses around them. The second way to do so is a mapping diagram. In a mapping diagram, you should only be listing each element once. So if you take a look at the right-hand side, that's technically not what we prefer. Right in there, you would only want to list that -1 once. And you put arrows from each input to their designated output. In a table, you put the input on the left and the output on the right, and there you list it more than once. And in a graph, you just put ordered pair points where they would be on the XY axis. Do not connect them with a line. Number 1, the monthly average water temperature of the Gulf of Mexico in Key West, Florida, varies during the year. In January, the average water temperature is 69 degrees Fahrenheit. In February, 70 degrees Fahrenheit. In March, 75 degrees Fahrenheit. And in April, 78 degrees Fahrenheit. How can you represent this relation in 4 different ways? I'm going to represent the relation, first of all, using ordered pairs. So in ordered pairs, just list the first value and then the second value. So we're going to call January 1, and then that means February is 2, March is 3, and April is 4. So that first ordered pair would be 1 because of January and 69 because that's the degrees in January. Then February's ordered pair would be 270, March's would be 375, which leaves April to be 478. Those are ordered pairs. I'm going to do the mapping diagram next. In a mapping diagram, you put the inputs and outputs in bubbles. Typically, you put them in order and you do not repeat anything. So you have an input on this side, put a bubble for those, and an output on this side, put a bubble for those. And you put them in order. So 1, 2, 3, 4 over here, 69, 70, 75, 78 over here. And then draw arrows between what maps to each other. It's a mapping diagram. Next, I'm going to do a table. Looks very similar to the mapping diagram, only it's in a chart instead. So for a table, put the input on the left and the output on the right, and just list them the same way. So 1, 69, 2, 70, 3, 75, and 4, 78. It's a table. The last one we're going to do is a graph. Typically speaking, you want to do a graph on graph paper. I'm going to skip that this time because of the smartboard. I'm also going to skip all of the other quadrants other than the first one because everything is positive. So along the bottom, put your input values, 1, 2, 3, and 4, and label that. Along the side, you're going to put your output values. Now this happens to be temperature in degrees Fahrenheit, but because the lowest temperature is 69, I'm going to truncate the y-axis and start it at 70. And then I'm going to go 75 and 80. You can choose whatever you want, just make sure you label it. And then plot your ordered pairs as best as possible. So 169 might be there, 270 just a little higher, 375, and 478. Just don't connect them with a line because it's meant to look like a scatter plot. Domain. The domain is the set of inputs, also called the x values, the x coordinates of the ordered pair, which means that the range is the set of outputs, also called the y coordinates of the ordered pairs. So domain is what goes into a relation, and range is what comes out of a relation. So in number 2, what are the domain and range of this relation? So we're going to list them using set notation. So D for domain. And then you end up putting what I call a squiggly looking brace. The domains are the first values. You can try to put them in numerical order, but that's not a requirement. I'm just going to list them in the order in which I see them. And then close the funny brace. Do the same thing for range, but now we're talking the second value. So the range here is 14, 7, 0, -18, and -99. Domain comes first, range comes second. A function. A function is a relation in which each element of the domain corresponds with exactly one element of the range. So what that really means is that the second number can only be the only number that's repeated, the first cannot. So if the first number, if the input repeats, it has to go to the same second number or the same output. So if you take a look at example 3, is the relation a function? In letter A, take a look at all of the inputs. So remember that the inputs are the numbers on the left. They cannot be repeated. And in letter A, that would mean that you can't have more than one arrow going out of each of them. But because -3 maps to -2, 0 to 7, and 4 to 1, this is a function. Every value on the left goes to 1, and only one value on the right. When it comes to ordered pairs, you really want to focus on the first value. And if you have to, say them in your head and make sure you don't repeat them. So in letter B, -7, 9, 14, and 7. None of those values are repeated, so this is okay. I do want to point out sometimes people would say, well, look, there's a 14 here and there's a 14 there. It's okay if the second value repeats. It's not okay if the first value does. Letter C, how does a mapping diagram of a relation that is not a function differ from a mapping diagram of a function? So a mapping diagram is like letter A. So I'm going to show you on letter A what it would look like. Letter A is a function. It would not be a function if it had an arrow being repeated. Like if 4 went to 1 and to 7, like the blue one I just drew in, that is not a function. So when it says how does it differ, how does a mapping diagram of a relation that is not a function differ from one that is? It has 2 arrows coming from one input. Not 2, coming from one input. Like the blue arrow I put in letter A. That's how you can determine whether a relation is a function based on mapping diagrams and ordered pairs. They won't do it so much from tables. The last thing we need to talk about is how you can determine whether a mapping diagram or whether a graph is a function or not. Just a quick recap of the answers for you, try it for you. Just in case you missed letter B, the reason that letter B is not a function is because of this 3 to -8 and 3 to 2. So the last thing we need to discuss is the vertical line test. The vertical line test says that if a vertical line passes through more than one point on the graph of a relation, it is not a function, which means if you learned this before, your teacher probably told you something about like a pencil, if you pass a pencil through the graph. So I'm going to do that. I'm going to draw a line here so you can see it. That's a vertical line. If at any time I'm bringing this line across, like right there, and it touches in more than one place, it's a fail. So like right here, and there are lots of places that this occurs, the red line touches the black circle in 2 places. So this is not a function. We'll look to make sure it passes. So if I take that same vertical line and I start passing it through the second picture, at no time through that passing does it touch more than once, so this is a yes. That passes the vertical line test. It is a function. And the last one. The last one also passes the vertical line test. I'm going to show you just for 1 second something that you won't see right away but will come up. If you have an open circle on the same graph as a closed circle, so like if I put this vertical line right there, it's technically going through both that closed black dot on the top and the opened green one on the bottom. If that were the case, it still passes because the open point doesn't really exist there. If they were both closed, it would be a no.